Hi, I'm Reggie, and welcome to Read Tech. Today, I'm going to describe how to set up Pi-hole on a Raspberry Pi 4 using Docker Compose and Docker containers for a super easy deployment. I'll also show you how to update a typical Linux system to use Pi-hole as the default DNS provider. And I'll definitely include a link to the main Pi-hole GitHub that includes the Docker Compose YAML configuration file that I based. It's actually on the screen right now that I based this video on, and it also includes documentation on other options that I did not use. It is very versatile, and there are many options. In this video, I will not cover using Pi-hole as your network's default DHCP server, because that's not how I'm going to use it, at least not right now. I'm going to do a little bit of testing, and maybe I'll create another video later that shows how I integrate it into my overall home network. But so let's start off and just answering the question, what is Pi-hole? Other than having a very funny name, you heard, most people have heard shut your Pi-hole or whatever. It makes me laugh when I think about it, and definitely evokes that thought. But Pi-hole is an open source system that is designed to reduce or block ads at the network level. The beauty of it working at the network level means that you don't have to install any additional plugins or ad blockers on individual systems. As long as it's using the Pi-hole for DNS resolution, you should get a fairly decent amount of ad blocking performance. So Pi-hole uses blacklist to literally black hole DNS requests that are made by websites or applications that are known to serve ads. So that includes both host and domains. When a DNS request is made to a Pi-hole DNS server, if those requests are not in the blacklist, it passes it on to another DNS server on the internet. So it basically, and then, when it receives the response back from the internet DNS server, it passes it back onto the client, and the client, does what it needs to do in order to pull down the content from that host. And that's basically the how Pi-hole works in a nutshell. So let's jump over to how we actually get this running. So one of the things that we're going to fully assume here is that you already have a Raspberry Pi that's running Raspbian, and you already have Docker and Docker Compose installed. If you need help with that, I have a couple of videos that I'll link here that go into how to set that up and some of the basics with Docker Compose. But let's just assume that you already have it in place. So on the GitHub site, there is a Docker Compose file that includes more or less this configuration file. So what we have here is we're using Docker Compose version 3. And for the Pi-hole section, we've got the container name. We're just going to call it Pi-hole. The image that gets pulled down is Pi-hole/Pi-hole, and we're using the latest version of that. We move down to the ports that are going to be forwarded from the main host interface. Port 53, both TCP and UDP. That's the default set of ports and protocols for DNS request. Then we go to port 67 UDP, and that is the default DHCP port. Like I said in the introduction, we're not going to be using the DHCP server that is included with the Pi-hole container. It is running DNS mask inside of the container, and because of that, it actually does bind to port 67. So that's why that is there in the list. Then we go to port 80, which is just the, it's for HTTP, and that is how the Pi-hole administrative web interface is served up. We've got some generic things here. So time zone, I'm in Eastern time zone, so America is New York. The password, you can set the password here. I'm not sure if there are other means of setting the password. I haven't done that research, but there probably is a way to put it in a configuration file that that could be exposed only on the file system, and then you could protect that file. But by default, the web password for the administrative console is specified here. Then we move down to volumes, and these two directory locations are mapped into the container specifically for the purpose, like most other things, configuration files and data that you want to preserve between restarts or regeneration of the actual container itself. So you don't start off from scratch with all of your data and such. Let's see, then we've got two more options. Cap add. So cap add, basically with a net admin capability added to this container, allows the container to make modifications to the host network interface. I believe that is required mostly because of the DHCP service. I left it in for simplicity's sake. It doesn't seem to have any negative effects, so it's still there. And then we've got the very, very, very nice restart unless stopped. So for services like this that you want to run continuously, you absolutely want to have this option set, and they have that set by default. So, all right, so that is our compose file. So we're in here with our mapped configuration directories and the Docker Compose YAML configuration file. So now we're going to run a Docker Compose up, and we're going to do a detach. Now, when you see this run, you'll see that the network is created and Pi-hole is created. You don't see it pull down the Pi-hole, the latest Pi-hole Docker image file because I've already done it, and it saves a little bit of time on the video as well because nobody really wants to see that. But looks like everything is running. So we do a Docker PS. We see that Pi-hole is there. It's running the latest image, and we see all of the mapped ports. So the first thing that we can do is we can go to the actual web admin port. And yes, we do want to go to the admin panel. So since I've run this previously, you can see that a couple of clients, which includes the actual Pi-hole container itself, as well as the an additional, the Linux client that I'm going to show you guys in a couple of minutes here, it's gotten quite a bit of activity here. And I will log in. I will use the password readtech that I set up for in web password in the Docker Compose file. We get a little bit more statistics, and you can look at the query log. Lets you know where the the forwarded DNS request, the type of records that are actually being looked for. It's pretty extensive. And you even see some examples here of sites that have been whitelisted. You also have the ability over here to manually update whitelist with domains and regular expressions, which is pretty cool, fairly flexible. So if you run into an issue where a site that you normally go to ends up being blocked by Pi-hole, you can add it to the whitelist, and it will actually pass that DNS query on to DNS servers on the internet, so your clients will be able to reach those sites. And you've got blacklist. So again, this serves the opposite purpose. If you are running into something that a site or an application that is allowing ads through, things that are not blocked by the default blacklist that are included with Pi-hole, you can add them here and put a description or whatever, and now you have just like the whitelist, again, a locally configured for your network and your personal usage, which I think is one of the most powerful things about Pi-hole in general. So so that is pretty cool. Okay, now let's go to my Linux machine, which is a generic CentOS server that I just have running on VMware Workstation Player, something quick and dirty. So what I basically did is went to network settings. You go to IPv4. As you see, we're using DHCP to acquire our address, which is coming from the VMware network stack. By default, automatic for DNS is turned on, but I've turned that off. And then I've configured basically the IP address of the Raspberry Pi host that is running the Pi-hole container as the primary DNS, and then as secondary and beyond, I'm using the Google Internet, primary and secondary DNS servers. So once that is actually set, all of our as long as the Pi-hole service is up and running on the network, all DNS requests will go through the Pi-hole server, and it should block ads. So the first test, there's this Pi-hole ad tester, and we go here, we see that there are no ads on the page. So it looks like Pi-hole is doing what it's supposed to do. If we go back over to the query log, we can actually see that we're doing the DNS queries from that page, and we've got blacklist for a number of different things here. All manner of blacklisting. So it's doing exactly what we want it to do. To show you what it looks like when ads are not blocked, we can go back and do a Docker compose down. So we're stopping Pi-hole. Do a Docker PS, show that there's nothing running, go back over to the Pi-hole ad tester. We'll click this again, and actually we will do a reload so it actually doesn't get cached. And we see a lot more activity. We see our first ad here, so several ads that normally would have been blocked by Pi-hole. So it's working fantastic. And shout out to Fuzz the Pi Guy. This is a great test page for testing out Pi-hole. Definitely appreciate that it is available. Okay, so that is it for Pi-hole. Looks like, you know, a very useful service. I think I'm going to incorporate it into my network, and I'm going to do that at the, you know, at the my router level. I probably will not use a DHCP server that is in the Pi-hole container, but yeah, it's great. It's great. I like this a lot, so I'm definitely going to use it. Thanks for watching. I hope you got some use out of this video, and maybe it'll help you to explore Pi-hole as an ad blocking solution for your home. If you like this type of content, please subscribe. We are working really hard to try to get to 100 subscribers. That's my next goal. You know, a thumbs up definitely helps with the algorithm. Will bring more people to watch my videos. Again, thanks a lot for watching, and I will see you in the next video.